So here I'm gonna try and demonstrate why this using the calculator can be efficient. We have this circuit here. Um, we're gonna calculate the total impedance of that circuit using the calculator pretty quickly. So XC was calculated to be 12 ohms and XL 20 ohms. As you can see, it's a series circuit with a resistor, an inductor which has a resistant component, resistive component, and the inductive component, and the capacitor. Now we're going to write it out like this. Z is equal to R resistor plus R coil plus I XL minus XC, and that's going to be 6 plus 5 plus I 20 minus 12, and all that is in ohms, right? Now, just to demonstrate that the calculator here it's pretty powerful, is we're gonna just do 6 plus 5 plus, let's put that in bracket, 20 minus 12 close bracket I, and there you'd have Z, which is gonna be equals to 13.601, and that's gonna be at an angle of second function exp at 36.027 degrees. So there you have it. If you want the R and X component, all you gotta do is go to the calculator here in the second function and put it in the XY, and there you would get Z then equals to 11 second function exp to see the other portion of it plus 8i. And just to go back in the book here, there you have RT is equal to 11. So if we go back to the book here, you see they work it out as 11 for RT. Your XT is 8, your ZT is 13.6, and your power factor angle is 36. Same thing we get here. Few punches of the calculator, we get 13.601 at an angle of 36 point that. This even helps with less rounding off, so you get a more accurate answer in the end. And as you see, Z here, which is your impedance, is equal to R, which is 11 ohms, plus your XT, which is 8 ohms. So 11 plus 8i. Now, if you want to find IT, it's pretty simple. We're going to take a voltage as the reference. So this 120 here, we're just going to write it out like this. IT is equals to E over ZT, and that's 120 at 0 degrees because it's the reference, over 13.601, an angle of 36.2027. You may not need to show the angle, but when you go further, you're probably going to need the angle of the current. If you have stuff in parallel, you need to add that with the total current. For this one, just another feature of the calculator here, without clearing anything on the calculator, we can just go ahead and type 120 divided by the answer for the last the impedance that we calculated is still in the memory of the calculator. So to get that memory out, you just press second function, no sorry, alpha, and if you see here, ans, that's the answer that was in the memory, and it will then divide that 120 here by this value that we had calculated, or this value, which is the same. When you press equals, then there you go, you're gonna get it as, and I think that's in your rectangular form, so 7.135. Second function, exp minus 5.189 I, and all that is your current, or you put it in polar form, so second function, or that's your IT 8.823. And if you need the angle, second function, exp minus 36.027 degrees ampere. And that's what the book had there, 8.824. And our value that we calculated here is more accurate because we didn't do any rounding. We're working with the true values.